G3 Cooling Mod Part 2. This is what it looks like after I've trimmed off the edges here a little bit with the Dremel tool. The one thing they'll have to compensate for is there's like a little lip that runs right across inside here. So I'm going to have to find some kind of plate to put over here so I can get a good contact from metal to metal on the cooling block there. And it fits in there really nice. I mean, it's nice and tight. The next thing to do on top of that is I have to cut a couple of holes inside here so I can put this plate down and screw it down to hold the cooler in place. I think I better just get rid of this fan now. I think what I'll do is I'll cut off a little bit of on the end here in case I decide I want to put the fan back on at a later date. But that's what it looks like now. Now we just gotta assemble it and see what it does.
Could use a Peltier cooler. That's the kind of device that has heat coming off of one side, and then the other side has a cooling block on the other side of it. The only problem with this is that it runs at a very high amperage. I mean, it's talking 2 amps on there, and 2 amps is a little bit too much power that I want to spend out in the field. This wouldn't drip water on it, but it also produces a lot of heat that comes off the back side, and you have to have some way to exhaust that heat. Basically, for every side that, this has a cool side, it also has a hot side on it. So it's just using a lot more power than the water solution is. The water solution is only using 0.37. This is using 2.1. I have to figure out a way to drill some holes through here and allow the nipples of the cooler to stick through the plate. It's pretty close to using one of these holes right here on the corners. Hold this on. It's going to be these screws on the outer edge. So these screws for the outer edge, they're really not very long, so I might have to get longer screws for that too. One of the things I noticed last night when I was doing my stress test on the ice is that the ice was melting rather quickly. I also, this was inside the house when I did this test, and I also had the hoses like apart from one another, the intake and the outtake. So what I'm thinking of doing here in this situation is maybe getting some kind of insulation to cover the hose and bring the hoses together to help retain that the cold water together. Of course, if I bring it out with more surface area like this, then of course it's going to get warmer and cause the ice to melt faster. So that's another little thing I'll have to look into. A cover mod on here, what I did is I just cut off the inside little ears right here. You can see these little ears. I just took a Dremel tool and just kind of cut out around it. It even went inside these edges on opposite corners like that. And when I did that, then I could take this plate and put it over the top of it like that, and now it fits there pretty good. Well, there's the original screw right there, the silver one, and there's the replacement screws I have, which are these black ones here. Water block installed on there with the screws has a very nice tight fit on here. It's going to hold the water cooler right directly to the CCD. Now the only other challenge I have is the power cable here. The power cable that came with the camera is a 90-degree angle. It's just barely fits in there. I might have to adjust that. It appears that the power will work the way it is if I plug it in to the computer. Hear the ding, that means that it's connected to the camera through the USB, so there must be power going there. I like the way this is turning out. The water cooler, or the water block, fits in there pretty good, and just had to cut out 2 of the corners there for it to sit down into it, and then it just a little bit longer screws on the edges there. There's a little bit of a gap there, but I'm not going to be concerned with that gap. I'm just going to leave that gap the way it is, and it feels nice and solid. I think this will work really well. Here's the copper plate I made to go inside the camera here. If you remember, I pointed out there was like a little lip that was along the bottom here, and this copper plate will level it out so there's no gap between the heat sink and then the water cooler, or the water block. This particular piece here, it's about 34.5 millimeters across. It's 40 millimeters long, and this piece of copper that I have here is about 1/2 millimeter thick, and this just fits in like this, and it fits in there really nice. It's nice and tight. What I'll do is I'll put in some thermal grease inside here so that the cooling block will sit here really firm and secure. Going to apply some thermal grease to the base here. This should have a pretty good even dispersion of the thermal grease across most of the area. I see that there's some areas missing right up in here on the edges, so I'll apply just a little bit more there. Okay, that looks like it's a nice snug fit on there. Now I'll put another layer of thermal grease right on the top where the cooling block is going to go. Now I'll take the cooling block, put that on there. Okay, now I've got a good thermal grease fitting. There's no spaces or gaps in there. So the next step is to put the cover plate on. So there it is. Heat sink and everything on the G3 camera. Got a water cooled block on it. Have a pump that's tested with it. So the next step is to get this out and see what kind of results we can get with it. Looks pretty good.